Hi, and welcome to my video on proofs with rhombis. Proofs with rhombis. Rhombis is the plural for rhombus, R-H-O-M-B, rhombuses, yes. So rhombi is the plural for rhombuses. Let's look at the definition of a rhombus. A quadrilateral with four sides equal. Here we have a quadrilateral A, B, C, D, and we have AB equal to BC equal to DC equal to AD, but they all have one stroke each, so they're all equal. So a quadrilateral with four sides equal is a rhombus. Let's do a proof on a rhombus. Proof, a rhombus is a parallelogram. And again, you can pause your video at any time and work these proofs out. My videos are designed to do that. So here we're given MATH is a rhombus. Prove that MATH is a parallelogram. So a parallelogram has opposite sides equal, opposite sides parallel, opposite angles equal, diagonals bisect each other, and consecutive angles are supplementary. So let's find one of those reasons. Here we go. MATH is a rhombus. Rhombus given. Number two, if we have a rhombus, that means we have angle M, and we have angle M, angle A, angle T, and angle H are right angles. Definition of a rhombus. And since we have right angles, that means that angle M is equal to angle T, and angle A is equal to angle H, and the reason is all right angles are equal. And as a result, we have MATH is a parallelogram, and the reason is we have two pairs of opposite angles are equal. So a rhombus has all right angles, which are all the angles are equal. So these are the two that I picked out, which are opposite angles in this figure. M and T are opposite, A and H are opposite. Therefore, we have a parallelogram because two pairs of opposite angles are equal. And the properties, a rhombus has all the properties of a parallelogram. A rectangle has all the properties of a parallelogram. And so does a rhombus have all the properties of a parallelogram. So every rhombus has opposite sides parallel. Opposite sides equal. Opposite angles equal. And they have the diagonals bisect each other. And we have the consecutive angles are supplementary. So that's the same as a rectangle has the properties of a parallelogram. And these are all the properties of a parallelogram. And again, let's do a proof. The diagonals of a rhombus are perpendicular. So let's say that TRVA TRVA, make sure, is a rhombus. And we have the proof, and there's the diagonals. So it's the diagonals A, R, and TV intersect at O. So AR and TV intersect at O, and we're going to prove that AR is perpendicular to TV. These are the two that prove the diagonals of a rhombus are perpendicular. So here we go. And the diagonals of a rhombus are perpendicular. Let's see. We have a rhombus. TRVA is a rhombus. And that's given. So if the diagonals are going to be perpendicular, I probably need. We know that these two angles are going to be equal. So if I can get those angles equal, I can have them perpendicular. So let's see. Here we go. How we do it. I want them perpendicular so the diagonals bisect each other. So I have RA and TV bisect each other because the diagonals of a rhombus bisect each other. Hence, we have TO equals VO, definition of a bisector. And we have RO equals RO, common side to both triangles. And we have, it's a rhombus, so we have TR equals VR, definition of a rhombus, which is all the sides are equal. And so we have the triangles congruent, triangle ROT and ROB. And they're congruent. We have, they're bisected, common side, these are equal. So that's an SSS congruency. Now I need to get them perpendicular. So we have angle 1 equals angle 2, CPCTC, belonging to these congruent triangles. And that means that these angles are equal. That means that RO is perpendicular to TO, because if two segments meet to form congruent adjacent angles, then the line's got to be perpendicular. If two segments intersect to form equal adjacent angles, then the segments are perpendicular. And that proof was done in the unit on congruent triangles. So that means the diagonals of a rhombus are perpendicular. And a rhombus is a parallelogram. Okay, let's continue. The diagonals of a rhombus bisect each other, and the diagonals of a rhombus are perpendicular. That means that the diagonals of a rhombus are the perpendicular bisectors of each other. So if A, B, X, Y is a rhombus, that means that AX is the perpendicular bisector of BY. AX is the perpendicular bisector of BY. And the perpendicular bisector, that means AX bisects BY, making BO equal to YO, definition of a segment bisector. And AX is perpendicular to BY, which means that if the perpendicular angle 1, 2, 3, and 4 are right angles by the definition of perpendicular lines. And also, they're the bisectors of each other, so that means YB is the perpendicular bisector of AX, which means that BY bisects AX, making AO equal to XO, AO equal to XO, by definition of segment bisector, and BY is perpendicular to AX because it's perpendicular bisector. So again, in a rhombus, the diagonals not only bisect, but are perpendicular. So the diagonals are the perpendicular bisectors of each other. Okay, let's do a proof again. You can pause the video at any time. The proof here is prove the diagonals of a rhombus bisect the opposite angles. Okay, so we're given that F, E, H, I is a rhombus. So notice a rhombus is given. And it says that we're to prove that they bisect the opposite angles. To prove that 1 equals 2, so they bisect the opposite angles. So we bisect this angle and this one. They bisect this angle and this one. So they bisect opposite angles. Well, the diagonals of a rhombus bisect not only opposite angles, but bisect any angle. The word opposite is here, but we could also say the diagonal of a rhombus bisects all angles of the rhombus. So let's prove that 1 equals 2, 3 equals 4, 5 equals 6, 7 equals 8. So here we go. And we're given a rhombus, F, E, H, I is a rhombus. So we're going to use the properties to prove that 1 equals 2. Let's do 1 equals 2 first. So we have F, E equals HE, definition of a rhombus. A rhombus has all sides equal. Now we have to do that FM equals HM. FM equals HM because the diagonals of a rhombus bisect. The diagonals bisect each other, which means I should have said, well, the diagonals bisect each other, therefore these are equal. Okay, took a little extra step out of it, but because they bisect, then the segments are equal. And we have ME equals ME, common side to the two triangles, means the triangle are congruent. Triangle EMF EMF is congruent to EMH. And let's see, we got those first. If those are second, and these are the third ones, there they are there. And that's an Sss Congruency. And that means that angle 1 equals angle 2. CPCTC. So that's one pair. So if I wanted to do the other pairs, then I would deal with these two triangles, FMI and FME. And then if I wanted to do these two angles equal, I would deal with FMI and HMI. And if I want to do these two, I would deal with these two triangles, HMI and HME. Or another way is I could say that the sides are parallel here, and these angles are equal, and therefore, and these sides are parallel, so 2 equals 3, and because 1 equals 2, then 3 is going to equal 4. And then I could deal with parallel lines here, and deal with these angles with the congruent triangles. So I did one pair, so we can also do with, again, 3 more different pairs of triangles will give me 5 equals 6, 3 equals 4, and 7 equals 8. So that's the proof that the diagonals of a rhombus bisects the angles of the rhombus. Okay, let's do some more proofs, some practice. Given that MATH is a rhombus, MATH is a rhombus, MX equals TY, prove that XA equals YA. Okay, so we have MX equals YA. That's a given. And we also have that MATH is a rhombus. Again, I could have put all 2 reasons into one, but I just kept them separate. Now, we have MX equal to YA. MX equals, no, I said YA. MX equals TY. Sorry about that, that's a TY. I don't know why I wrote that down, but I probably looked at this one right here. So MX equals TY, given. There they are. Now, I need to prove other parts of the triangle congruent. So, we have MA equals TA, because they're the sides of a rhombus. Definition of a rhombus, all sides of a rhombus are equal. So I selected these 2 sides are equal. And now I have, let's go with 1, 2, 3, 4. We have angle 2 is equal to angle 3. Opposite angles of a rhombus are equal. That means that we have 1 and 2 are a linear pair, and we have 3 and 4 are a linear pair. Definition of a linear pair. That means that angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4, straight angle. That means that angle 1 is equal to angle 4 by SAT. 2 equals 3, and they're supplementary. So supplement angle theorem says the supplements of congruent angles are congruent. So 1 and 2 are supplementary, 3 and 4 are supplementary, 2 equals 3 in number 4, 2 equals 3, therefore 1 is equal to 4, SAT. So now we have the triangles, enough to have the triangles congruent. The triangles are congruent. What triangles? XMA, and XMA goes with YTA. And that's a side angle side. Congruency, and that makes, as a result, XA equal to YT. CPCTC. And the proof is done. We're using the properties of a rhombus, which is mainly that all the properties of a rhombus is also the properties of a parallelogram. Opposite sides equal. Opposite sides parallel, but we needed to get these MA equal to AT because they're in the two triangles, and that's the property of a definition of a rhombus. Okay, here we go. Number 2. Pause the video and work this one out. We're given that AFBC is a rhombus. We're also given that ABCE is a rhombus. And we want to prove that AFB is an equilateral triangle is equilateral. So, let's write down one of there should be some. Here's a rhombus. So how are we going to, what parts of the rhombus are we going to use? Well, if you size it up, this is a AFB, the triangle AFB is equilateral. That means the triangle AFB has all the sides equal. So I have to use the sides of the rhombus here to get equal to the sides of the triangle. So the triangles are, I got this rhombus AFBC. I have AF equals FB equals BC. And that's the definition of a rhombus, because a rhombus has all the sides equal. Now, I have AF equals, sorry, I said AF equals, where did I get EB at? AF equals, that's an F, FB. AF equals FB equals BC. I weren't supposed to put that one in right now. So this is the rhombus. So AF equals FB equals BC. Okay, here it is. Now I'm going to use the other rhombus. ABCE is a rhombus given. So I'm going to use parts of this rhombus. So here's the rhombus ABCE. So that means that I already have this one marked with one stroke. So I have AB equals BC. Definition of a rhombus. So now you can see that that's one stroke, so I had to put one stroke on this one. So I picked up, this is a rhombus, let's just go over it again. This is a rhombus, so these three sides, even this one, is equal, but I only need these three. in this rhombus, A, B, C, E, these two sides are equal. Now, as you can see, that all of them are marked 1 strokes, so that means that AF equals FB equals AB by transitive property, few transitive properties. And so notice, again, these 3 are equal, and BC is right here. BC is here in this set. BC is in this one. So that means that AF equals FB equals AB. And that means that triangle AFB, make it a B, is equilateral. And that's the definition of the QUI definition of an equilateral triangle, which is all sides equal. And number 3, prove a parallelogram with a pair of adjacent sides equals a rhombus. So we have a parallelogram, so we'll go H, I, J, K is a parallelogram. So that's a given. With a pair of adjacent sides equal. So let's make H, I equal to IJ. That's the pair of adjacent sides equal. So we got to prove that H, I, J, K is a rhombus. In order to prove a rhombus, we need all sides equal. So we have HI equals IJ as a pair of sides given. So we have to get all the sides equal. So we have a parallelogram given. So in the parallelogram, I have HI equals JK, and I have HK equals IJ. In other words, we have HI is equal to IJ from here. Now we have what did I say? JH, make that an I. Again, I'm not careful enough. HI is equal to JK. So that's 1 stroke, that's 1 stroke. HK, this one, is equal to IJ. IJ got 1 stroke, so that one must have 1 stroke. And so that's the opposite sides of a parallelogram are equal. So notice that we got here, HI is here, so HI is equal to IJ, HI is equal to KJ, and HK is equal to IJ. That means that HI is equal to HK. So what we have is that we have HI is equal to IJ is equal to JK is equal to HK, and again that's a few transitive properties. I say transitive once, but there's a few transitive properties making all these equal, and as a result we have H, I, J, K is a rhombus. And the reason? Definition of a rhombus. And what's a rhombus? A quadrilateral with 4 sides equal. And that proof is done. Doing proofs on rhombis using the parallelograms, using the properties of a parallelogram, etc. And another one to do. Pause your video and work these out if you wish before I do. If the diagonals of a parallelogram bisect opposite angles, then the parallelogram is a rhombus. So the diagonals of a parallelogram, so M, A, T, H is a parallelogram. That's given. And the diagonal bisects the opposite angles. So that means that HA bisects angle MAT and angle I got MAT MHT, because MAT in the parallelogram is opposite to MHT. So that's the given, and we got to prove that parallelogram is a rhombus. So we'll prove that MATH is a rhombus. And again, we need to prove all the sides equal. So let's start. We have what we have is MA is parallel to HT. So if MA is parallel to HT, that makes angle 1 equal to angle 2. So that's the definition of a parallelogram, because a parallelogram has opposite sides parallel. So that makes angle 1 equal to angle 2. And that's a PLT, alternate interior angles equal. So now we have angle 1. Let's see what we have. We have angle 1 is equal to angle 2, and put 3 here. We have that HA bisects angle MHT, given, and because it bisects because HA bisects MHT, angle 2 is equal to angle 3. Definition of angle bisector that we've done in the congruent triangle proofs as a property of an angle bisector, but we use it in that chapter also. Number 5, we have, because we have HM, we have these two angles equal, so 1 equals 2 and 2 equals 3. That means that angle 1 equals angle 3 by transit. 1 equals 2, 2 equals 3, so that means that 1 equals 3 by transitive property. Again, 1 equals 2, 2 equals 3, therefore 1 equals 3 transitive. And as a result, we have MH equals MH equals MA, and that's the converse of the ITT. Because we have two angles equal in a triangle, the side opposite of those angles, MA and MH, are equal. Now we have MA equals HT, and we have MH equals TA, because they're opposite sides of a parallelogram are equal. And as a result, if you look at all these, we have MA equals AT equals HT equals MH by a few transitive properties, more than one. And again, that's transitive in right here, 6 and 7 puts them all together. And as a result, we have MATH is a rhombus, because all the sides are equal in number 8. Definition of a rhombus. All sides equal. And one more proof to do before we end off this video. Again, proofs take time. Proofs are normally difficult. Students have trouble. And there's a lot of thinking going on, a lot of reasoning. And the last proof, pause the video and work this one out if you wish, your choice, or here I go, I'm going to work it out. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Okay, we're given a parallelogram P, Q, R, T is a parallelogram. And we're given the diagonals are perpendicular. So we're told that PR is perpendicular to TQ. So we got the proof. So what I'm going to do is I'm going to say that H, the diagonals are going to intersect at H. So I need intersecting at H. The diagonals are perpendicular and they're going to intersect at H. So I need to say that, prove that P, Q, R, T is a rhombus. Again, I need all the sides equal. I have a parallelogram, so that's a start. P, Q, R, T is a parallelogram, given. And as a result, P, Q equals TR, and PT equals RQ. Opposite sides of a parallelogram are equal. And now I need to get a pair of adjacent sides equal. So we're told that the diagonals are perpendicular. So that means I have angles here and here. So because the diagonals are perpendicular, I'm going to now write down PR is perpendicular to TQ, given that angle 1 is going to equal angle 2, because perpendicular, that's the perpendicular symbol, perpendicular segments form congruent or equal adjacent angles. So these two lines, PR is perpendicular, so these two angles here are equal. Actually, they're right angles, and all the right angles are equal. It's just a quick way of saying it. Remember, 1 and 2 are right angles because of perpendicular, and all right angles are equal is another way to say this. But we did prove this statement in congruent triangles. So if you want to say that 1 and 2 are right angles, by definition, a perpendicular line, and then say all right angles are equal, you still end up with 1 equals 2. Okay, and we have PH equal to RH, and the reason, because the diagonals of a rhombus bisect each other. And hence, let's see, do I have enough yet? So I have angle 1 equals angle 2. I have PH equals RH. Oh, I need this one. QH equals QH, common side. And now I have the triangles congruent, triangle Q, H, P, and goes with Q, H, R, Q, H, P, Q, H, R, and that's the second one there, so that's QH equals QH, so that's an SAS congruency. Side, angle, side, side, angle, side. And as a result, that gives us PQ equals QR, or RQ. That's CPCTC. And number 9, we have, they're all equal up here, so that means that PQ equals QR equals RT equals TR. I just went around. I said they're all equal by transitives. Many transitives. Dealing with number 2 and number 8. So here they are, here they are, opposite sides equal. Now we got the pair of adjacent sides equal. So we have them all equal. And as a result of all of them being equal, P, Q, R, T is a rhombus. Is a rhombus. And the reason, definition of a rhombus, which is all sides equal. So there's some proofs on rhombi. The previous video had proofs on rectangles, and previous video to that had proofs on parallelograms, and they're all related, all these properties. And again, if you like my video on rhombi, click the like button, subscribe to my channel. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.